Okay, so we're now on to the discriminant and the nature of the root. So there's a very specific part of the quadratic root formula, that bit under the square root, that actually tells us something quite important about the quadratic itself. Okay, so we're going to just watch me kind of go through these examples here, and yeah, you should understand what I mean. So we've got three different graphs here. If you look at the quadratic, it's x squared minus 4x plus 3. That's this one. We've got x squared minus 4x plus 4. We've got x squared minus 4x plus 5. So you can see that the difference in the graphs are pretty much they are the exact same shape. They're just slightly in different kind of locations and relative to axis. Okay, so what we've done here is we've got the values of a, b, and c, and we've already plugged them into the quadratic formula. So what I want you to do is just do this in your calculator along with me and get the two values. So we're going to have x equals 4 plus and minus. So as always, we work out this bit first. So that's minus 4 squared. So you don't need to write this down, but just do it with me in your calculator, please. So minus 4 squared minus 4 times 1 times 3. So that gives me an answer of 4. And that is all over 2. So it's 4 plus minus the square root of 4. Square root of 4 is 2. So that's going to turn into x equals 4 plus root 4 over 2. And x equals 4 minus root 4 over 2. Okay, so it's going to be fairly straightforward. So that's just 4 plus 2 divided by 2 is 3. And 4 minus 2 is 2 divided by 2 is 1. Okay, and we can see that's quite clear. So we have two solutions here, x equals 1 and x equals 3. That's those 2 points there. Okay, and that makes kind of sense. Right, the next one is only very slightly different. The value of c has gone from being 3 to 4. And we're going to see how this impacts these solutions. So again, it's 4 plus and minus. Let's get the answer to the bit under the square root, please. So it is negative 4 squared subtract 4 times 1 times 4. And actually that turns out to be 0 over 2. Right, that's interesting. We've never had that before. So what does that mean? Well, that means that when we split this up, it's going to be x equals 4 plus 0 over 2. And x equals 4 minus 0 over 2, which is 4 divided by 2, which is 2, and that's 4 divided by 2, which is 2. So actually what happens here, if this bit under the square root is 0, it means that both of the roots are equal to each other. They're repeated. They're the same root, repeated. X equals 2, x equals 2. So there's actually only one point where that quadratic touches the x-axis there. That's important. And then if we look at this, if we try this one here, do this in your calculator, please, the bit underneath the square root. So you've got 4 plus and minus the square root of, so it's minus 4 squared. This time c is 5. So minus 4 squared. Take away 4 times 1 times 5. So that gives me an answer of minus 4. Over 2, and let's split this one up this time and see what happens. So do this with me in the calculator, please. So it's 4 plus the square root of minus 4 over 2, and x equals 4 minus square root of minus 4 over 2. So what are your two solutions this time? So 4 plus the square root of minus 4 divided by 2. Now, if you're getting an error, you're not doing anything wrong. That's correct. You can't actually get the root of a negative number. So you are going to get errors here when you try and do this calculation. And the reason is, if we go back and look at our graph, remember these solutions here, what we're figuring out here is the points where this quadratic cuts the x-axis. It doesn't cut the x-axis. It does not have any roots here. It doesn't even touch the x-axis. It doesn't go through it like the first one. It is too high up, so therefore there are no solutions to this one. Okay, so the reason I'm showing you this is that this little part of the quadratic formula, the bit underneath the square root, that actually tells us what sort of roots that the quadratic has if we were to graph it. So when the quadratic was a positive number, this bit under the square root was a positive number, it means that there are two different roots. When this bit under the square root is 0, it means that there's one root that is the same, repeated root. And if this bit under the square root is a negative number, it actually means there are no roots. Okay, no real roots. So that bit under the square root of the formula has its own little name, and it's called the discriminant. Okay, so there's a bit of information here. So let's just read through it, and then I'm going to get you to copy down these graphs here. So in each equation, only the value of c changes, yet the roots are all different. The nature of the roots is what we're talking about here. And all that it is, the nature of the roots is determined through the bit under the square root there, b squared minus 4ac, and that is called the discriminant. Okay, that is called the discriminant. And that tells us the nature of the roots. So are they real and different? Is it one root that's repeated, or is there actually no real roots? Okay, so here's the 3 rules that you need to remember, right? And you do need to remember these. So if the value of the discriminant, if b squared minus 4ac is greater than 0, then it means the equation has 2 real and distinct roots. If that discriminant, the bit under the square root, is equal to 0, it means there are 2 equal roots. And in equation 3, b squared minus 4c is less than 0, so it means there are no real roots. So those 3 definitions you need to remember. Okay, and I want you to make quick sketches of these 3 graphs right now. So draw 3 sets of axes side by side, and you're going to draw 2 quadratics on each set of axes. So the first one, you have the quadratics that are coming through, clearly cutting through the x-axis at 2 different points. So just copy these diagrams. You can see that there's clearly 2 separate roots in these quadratics. They're cutting the axis at 2 separate points. So that is, for this one, that would be b squared minus 4ac is greater than 0. And what we say is that there are 2 real and distinct roots. Okay, so it crosses the x-axis twice basically. So just copy what I'm writing down. You've got the axis, you've got b squared minus 4c is greater than 0, and you've got that means there are 2 real and distinct roots. Okay, 2 roots that are different. That's all it means. The second example is when we had b squared minus 4ac was equal to 0. In the above calculation we did, remember we got x equals 2 and x equals 2. We had one root repeated. Okay, so there are 2 real and equal roots. Okay, there's still 2 roots, but they're equal to each other. Okay, so sometimes the language in this is used slightly different. Some people like to say 1 real repeated root. I'm going to stick to 2 real and equal roots. Okay. And the last example is when we have a graph and the quadratics do not cut through the x-axis. It doesn't matter they cut through the y-axis, it's not important here, but they're not ever touching that x-axis. So this negative x squared graph isn't ever getting up to the x-axis, this positive x squared graph isn't ever getting down to the x-axis. So that is where the discriminant, b squared minus 4ac, is less than 0, a negative number. And that therefore means there are no real roots. Okay, and that word real is very important. It means there's no roots in the set of real numbers. Okay, you do get things called imaginary numbers, which you don't go into until advanced higher maths. But to be mathematically correct, we need to put that. We don't need to worry about that just now, but we do need to use this word real, okay? So there's no real roots, so the graph does not touch the x-axis. So you need to kind of make a clear note of this because that's important, and I'm taking a video of this lesson, so if you do need to go back and double check that, then that's fine. You can do that and fill that in. Okay, that's really important. Okay, so what we're actually asked to do in these questions at Nat 5 level is, to start off, we just actually have to find out a value for the discriminant. So just actually find out a value for that b squared minus 4ac part, and then state what that means about the roots. So we get our a, b, and c values, we do b squared minus 4ac. If it's a positive number, we say there are two real and distinct roots. If it's 0, we say there's two real and equal roots. If it's less than 0, we say there's no real roots. So that's it. That's all you have to do with this discriminant. Okay, so example 10, copy these down with me, please. And like it says in this grey box, whenever it talks about the nature of the roots, it's talking about using this discriminant, this b squared minus 4ac. Okay, so this is one of these kind of phrases that you need to, the more you practice it, you learn kind of what it's pointing you to do. So the nature of the roots is about the discriminant of the quadratic. Okay, so the first one is x squared minus 6x plus 9 equals 0. So just like if we were doing the quadratic formula, we would start by doing our a, b, and c values. That's all we're going to do to start here as well. So we would say that the value of a is 1, the value of b is minus 6, and the value of c is 9. This is nowhere near as much work as for the quadratic formula, because all we have to do is figure out a value for just b squared minus 4ac. So put in the numbers and literally just get a value for it and then state what that means using one of our three statements. So it's minus 6 squared, subtract 4, times 1, times 9. So just carefully put that in your calculator. So that's minus 6 squared, making sure you put a bracket in. So that's actually 36 minus 36, which equals 0. So you get an answer of 0 for your discriminant. No, so we look back to our note. What does that mean? If the discriminant is 0, that means you're in your head, you're thinking that means the graph comes and just touches the x-axis at 1 point only. So therefore, we would say there are two real and equal roots. Okay, the roots are going to be exactly the same. It just touches at 1 point. Okay, so two real and equal roots there. And that's it. We'll do the same for example B and C now. So in this next one, 2x squared minus 4x plus 5 equals 0. So A equals 2, B equals minus 4, C equals 5. Right, what is b squared minus 4ac? Well, that's going to be minus 4 squared minus 4 times 2 times 5. And then we just put that into a calculator. Okay, that gets me an answer of negative 24. So if the discriminant is a negative value, that's the third case. That means the graph doesn't cut the x-axis at all. So therefore, there are no real roots. Okay, so we found the value of the discriminant and we stated the nature of the roots. That's what we're doing here. And the last one, all we have to remember to do is bring everything onto the left side equal to 0. So I first need to do a little bit of rearranging. X squared minus 7x minus 4 equals 0. So just bringing that 7x onto the left hand side and get it equal to 0. So that's unusual but not uncommon. Not impossible to be asked to rearrange first. So just remember everything has to be in the same side equal to 0. So now we've got a equals 1, b equals minus 7, and c equals minus 4. So that's given me b squared minus 4ac is going to be minus 7 squared minus 4 times 1 times minus 4. So what is the value of the discriminant? And then state what that means about the nature of the roots. So that gives me an answer of 65. So it's a positive number. If it's a positive number, it means that there are two real and distinct, so different, two real and distinct roots. So that's like just your standard case where it's coming down, cutting the x-axis, turning, and then going back up at a different, back through at a different point. Okay, so the discriminant is equal to 0, it's two real and equal roots. The discriminant is a negative number, it's no real roots. The discriminant is a positive number, it's two real and distinct roots. If you can just remember those three things, then this shouldn't be too bad at all.